the video. Okay, so let's start with number 1. We want the area to the left of the 2.48. So please draw the 2.48 on the normal curve, and then we want the area to the left, and so you want to shade the area to the left. And then for the Excel part, anytime you're going from z to area, we use equals norm dot s dot dist. Good. 2.48, oops, 2.48 comma true. The answer to number 1 was this area is 0.9934. If you put 99, that's fine for the first one. Okay, any questions on number 1? Make sure to write comments on what they did and fix any mistakes. Don't worry about the scoring. I will handle that. You're here to just write beautiful comments so that your classmate knows what to do later on. Okay, next, area to the right of 2.48. So we want to shade this side. Well, we know the area to the left is 0.9934. How do we find the area to the right? Good, 1 minus. The total probability is 1. If there's 99% to the left, the 1% has to be on the right. So
did you have to shade?
Yes, it says it in the instructions. Now the reason why I'm doing this is because on the test, you're going to want to shade. So for this one, equals 1 minus norm dot s dot dist of 2.48 comma true. The answer is 0.0066. So 0.0066. If you put 0.01, that's fine. As long as you got the gist of it and you did it in appropriate. Okay, questions on number 2. Write beautiful comments for your classmate. Okay, next, we want between 2.48 and negative 1.28. Now, if we enter these values into Excel, we already know that when we enter the area to the left of 2.48, this green area, what was this green area when we did it in the first problem? It was 0.9934. Good. And then we want to get rid of this area here, this negative 1.28. So what am I going to do with the two areas? Subtract. So I want to do norm.s dis of this one, which I already did. It's 0.9934. And then norm.s dis of negative 1.28 to get this blue area, and then subtract them to be left with the area in the middle. So let's go ahead and type that in. I'm going to do equals norm.s.dist of negative 1.28 comma true. That's going to give me 0.1003. So this area here is 0.1003. And then to be left with the area in the middle, I'm going to subtract them because I want this area over here, and that's going to be 0.9934 minus the small area, 0.1003. And again, I can just do that all in one step in Excel. I could just do equals norm.s.dist of 2.48 comma true minus norm.s.dist of negative 1.28 comma true for a total answer of 0.8932. The final answer was 0.8932. Okay, questions on number 3? Yes.
Add them and subtract them.
You added them together and you subtracted one.
I added both of like the areas of each of them, and I did 1.28 and 2.48. added them and then I subtracted them.
Okay, the problem is if we add this blue area to the green area, we now have extra area. We're now double dipping on both the green and the blue area. So when we do that, we now can go over a probability of 1. So I'm afraid we can't do it like that. Yes, Nicole?
I think she means that like negative 1.28 to the left and 2.48 to the right, and then 1 minus the addition of both of them.
It should work.
So you did this side, and then you did 1 minus.
Both of those sides.
Okay, let me think about this. So you did equals norm dot s dot dist of negative 1.28, and then you added I'm supposed to do comma true, and I'm not doing that. And you did 1 minus this. Okay, so like over here, 1 minus this here. And then you did 1 minus that, and that gave you the answer. Okay, let me think about why that works. Yeah, what you did is you basically kept adding and subtracting things. So you did some sort of algebraic manipulation that did the same thing.
Like, say we do that on the test, is it okay? We only do your method.
The thing is, I need to go through that method to see if it works for non-symmetrical distributions. This one it works because we have a symmetry on the side versus the side. We had a non-symmetrical curve, it may not work. So I have to check to see if that method works for non-symmetrical. If it does work for non-symmetrical, you're fine. If it doesn't, then I'm highly going to encourage doing it this way because this way would work for non-symmetrical graphs. The symmetry has properties that let you manipulate it in such a fashion. Okay, good question. And that'll be on the video, so then I'll be able to remember and check it for you. Okay, so next we still need to do these two problems. Area to the left is 0.42. This time we're given the area, and we want to get the z-value. What do we use when we go from area to z? Are we going to use norm dot s dist? No. Inverse. Good. So I'm going to do equals norm dot s dot inverse of 0.42, and I get negative 0.202. That's the answer to number 4. Yes. Yeah, that's fine. Yeah, these two decimal places, so negative 0.20 there. Okay, questions on number 4. Okay, now there's 2 ways to do number 5, but I recommend doing it the way we're going to do it. Now you may see, oh, if the area to the left was 0.42, and if the area to the right is 0.42, oh, well, this is probably going to be 0.202, just the positive version of the negative one. Now that's true due to symmetry, but really, if you have a non-symmetrical distribution, that might not work. So we're going to do it the proper way. And what does Excel work with? In number 4, did I enter in the left area or the right area of number 4? Left. So Excel only works with left areas. Is 0.42 a left area? No. But can I figure out what the left area is? If I have 42% on the right, what percent do I have on the left? 58. Very good. So if you do 1 minus 0.42, you'll be left with 0.58, and that's the area on the left side. So my left area is 0.58, so that's what you want to enter into Excel. You want to do norm.s.inverse of 0.58. So you do norm equals norm.s.inv of 0.58, you get positive 0.202, and so that's the answer. Okay, questions on number 5. For today's quiz, if you didn't do it the method that I showed it, it's fine, but for the test, I want to see it with the method that's foolproof. This one's foolproof if you put the 0.58 into Excel. Okay, any other questions before we turn our quizzes in? Yeah, we can quickly see our quiz. Actually, after class, because we're actually running a little low on time. Yes. You want to put the 0.58 into Excel. What did you do?
Oh, I was in the.
So that's fine for today because it's symmetry, but in the future, I want to see the 0.58. It's right for today. Right for today. For today, if you did it any method and you got the right answer, as long as you did it on Excel, you're good. Okay, go ahead and turn your quizzes in. You know, I feel like I should hand these back real quick, just because you are, what we're gonna do is we're gonna have everything together. Okay, Sam Bailey, Sam Bailey's back up. Savannah? Yeah. Hannah H. Anderson. Just quickly take a look at it and then bring it up to the, or bring it back to me when you're done. Anna. Ava, Nathan, last teacher. Oh. Sorry, I get confused. David Brewster, Hannah Batista, Nicole, Lauren, David A. Rachel, Michaela, and Erica. So what I want everyone to do with their quiz, quickly write down on another piece of paper, if you want to write it on today's notes, that's fine. Quickly write down what the mistake was that you made, because what we're going to do in today's notes has everything to do with the quiz that you did. So quickly look through your quiz, write down any notes on today's notes. Write it down on today's notes because you're going to be turning the quizzes back in. As soon as you're done looking through your quizzes, I need to get it back. You can take a picture of it, that's fine. How about I just do this? Okay, I do need to get the quizzes back. So as soon as you've taken a picture and you've written down your notes, did I get all the quizzes? Okay, so starting the notes. Today we're going to look at the normal distribution again, but last time we looked at the z-scores. We're going to be moving away from z-scores into real life data. Here's what our notes look like today. Instead of looking at the z-scores, now we're going to look at a normally distributed population. How many of us have taken an IQ test before? I've never taken one. Anyway, if you take an IQ test, the mean of an IQ test is 100 and the standard deviation is 15. So what we're going to do is we're going to look at probabilities in this normal distribution. Z-scores are hidden throughout, but we remember learning Z-scores, and that's what's going to help us find the probability or the percentage of values between two values. Because we know normally distributed populations follow the empirical rule, 68% within 1, 95% within 2, and 99.7% within 3. So let's start with a little bit of review of z-scores. So do we remember the z-value? A z-value is the same thing as z-score. Do you remember what the z-value of a test score of 70 is? Let's quickly recap. How do we find the z-score? The z-score is the number of standard deviations either above the mean, getting a positive value, or below the mean, getting a negative value. So groups of 2, see if we can put our work down on trying to find the z-value of the test score 70. Okay, groups of 2. Did you write any notes down from your quiz today?
From my quiz?
Or yours is probably easy. Let me just go with the collector. It looks like you did it right.
Yeah.
Okay.
Just on here. Actually, you know what? I don't even realize -2. I just don't know.
Okay, because you're taking 100 and you're subtracting minus 100 is equal to, or 70 is equal to 100 minus 15 minus 15. So you're subtracting 2 15s. So do you remember how to find the z-value? Okay. So the z-value is the number of standard deviations away from the mean. So you take the mean from 100 and you subtract the standard deviation 2 times. Okay, let's go ahead and share some of our answers. So, what's the z-score of 70? -2. Why is it negative and not positive?
How do you find it?
Okay, we're gonna go over it. But why is it negative? Because the 70 is below. Good. So we start with the mean, which is 100, and then we're gonna take away the standard deviation. What's our standard deviation? 15. But do we just take one standard deviation away from 100? No. We have to take another 15 away from 100. So how many standard deviations did we take away? 2, or -2. That's another way to say that is we took 100 and we added how many standard deviations? -2 standard deviations. So the reason why we're putting it into this formula is because it's going to help us calculate the z-value formula. So I took 100 and I added -2 standard deviations. So again, let's put our standard deviation over here and then put our -2 over here. Just see that we're taking away 2 standard deviations. If you enter 100 plus -2 times 15 into your calculator, you will get 70. So if you do want to check that, you can. I can even do it real quick. So if we go into Excel and we do 100 minus 2 times, or I actually want to do plus a -2 times 15, we get 70. So that kind of gives us a formula here. But maybe we want to find the z-value of 90. Let's use the same formula here. We did the 70 equals 100 plus -2 times 15 to now find the z-value of a test score of 90. So let's go ahead and fill this top part in. In this case, Yeah, you're right. Okay. So, my bad. That's a mistake. These should all be in. So 90 is equal to, again, you want to put the mean and standard deviation in here, but if we don't know the z value, you can put another, you can put a placeholder from above. So remember we're drawing letters from the top. Okay, so let's go ahead and see if we can fill values in for number 2. Again, we're in groups of 2.
So it's just these standard deviations away from the mean. So the mean is 100 and 70, so it's -2 times 15 because we know 15 is standard deviation. No, it would be these would be 2/3 because it's 10 and the standard deviation is 15.
So what we can do is we can put a z in there because we should. Here's a hint. We're not sure what the z value is, so take the z symbol and just put the z in here, and then that'll help you figure out what the rest of it. That'll help you figure out what the z value is. Exactly.
Oh, just because it says.
Exactly. Okay, good. You guys are doing it right. Very good. Okay, let's check our answers. Did the mean and standard deviation change? No. So same thing as before with the 100. We know the 100, we don't know the z, we know the 15. So then I'm going to subtract 15 from both sides. So subtract 15 from both sides. So then when I do that, I get 90 minus 15 equals 100. Sorry, I don't want to subtract 15 from both sides. I want to subtract 100 from both sides. So this should be 100. And then I have the z and the 15 still being multiplied. So it's z being multiplied by 15. And now after I have 90 minus 100 equals z times 15, what am I going to do to both sides? Good, divide by 15. Very good. So once I divide by 15, and I'm going to write that down here. The 15 goes on the bottom. I still have the negative 100 on the top, and that's my z value. And when we do that, we end up with negative 2/3. That's the answer. Questions on number 2? So we just created a new formula. What's the z value formula? It's blank minus blank over blank. See if we can fill that in from the word bank at the top.
This thing is the average,
Yeah.
So let's go ahead and, in groups of 2, let's fill in what we believe the z value formula to be.
Z value.
The 90 is the, we're going to call it x. Yes. So, yeah, that's correct.
There we go.
Very good, very good.
Over you.
Okay, so let's fill in our z-value formula. The 90 right here, we're gonna call that x. That's gonna be our x value in the data set because that's the unknown value and some sort of test score is gonna give you that for our x. And then the 100, what symbol is 100? What's 100 again? Mean, and our mean is this symbol. So I want to subtract the mean and then divide by the 15, which is the standard deviation. So that's our z-value formula. So we're going to be using that again in the homework. Okay, moving on to number 4. We're going to need z-values because we want to find the percent of test takers between 70 and 130. Do you guys have a question? We want to find the percent of test takers between 70 and 130, but if we can identify the z-values, we may already know the answer. So here I gave you the z-value of 70 was -2, but maybe if we can figure out the upper z-value, then we may already know what the answer to this one is. So let's go ahead and fill in what the other z-value is and then identify the percentage of values between 70 and 130. You can use the z-value formula. If you already know what the z-value of 130 is, that's fine as well. You can use the empirical rule at this point because we haven't typed anything in yet.
It's not bad.
Oh, it's well, I thought we were just supposed to do C-score, so it would be 2.
Yeah.
So it's going to be 95% because it's 95%.
How is your final percentage? I'm confused.
At this point, let's use the empirical rule. So last class we learned the empirical rule was this one here. So like 60.
Oh, right, the rules that you can memorize.
Yeah, but we can type them into Excel as well. Let's go ahead and go over the answer. How many standard deviations above is 130? 2. Do I need to use the z-value formula? No, because I'm just adding 15 to go to 115 and then adding it again to get to 130. So my z-value is going to be 2. But if we use our formula for that, if you do the z-value formula and you do, that doesn't look like a z. Z equals 130 minus 100 divided by 15, you will get 2. Now, within 2 standard deviations, remember the z-value tells you this is 2 standard deviations above and this is 2 standard deviations below. Within how many, within 2 standard deviations is what percent of the data? Does anyone remember? 95%. So the answer is going to be 95%. So 95% of data within 2 standard deviations. So the answer is 95%. Any questions on number 4? Yes?
Sorry, how is 95%?
Empirical rule. With empirical rule, we know within 1% or within 1 standard deviation is 68. Within 2 standard deviations is 95. And within 3 standard deviations is 99.7. If I ask you how to do a problem like this and I say use the empirical rule, the empirical rule will be provided on the formula sheet.
Oh, okay, there's a formula, okay.
So you have to memorize each percent.
I don't recommend memorizing them unless it's gonna help you in class remembering things like this. Or if you have a little note that has the empirical rule. Empirical rule comes up a lot in this class, so it is a good thing to have down, yes.
Will we get the sheet, the formula sheet before we do the test, like we study with that?
Yeah, yes. So our test is a week from today, I just remembered. So my goal is to have the formula sheet posted by Sunday night. So if it's not posted by Sunday night, please email me, but I'm gonna send an email saying the formula sheet's been posted.
Can we add to it? Or,
So if you wanna add to the formula sheet, you can write a formula down and you can email it to me saying, can we add this formula to the formula sheet? And I will decide whether or not I wanna add it to that or not.
Does it give you the Excel stuff with what you type in?
Sometimes I do write Excel formulas on there, but I'm not gonna give directions on the Excel formulas, just like norm dist, norm.sdist. Yes, Nicole?
Can we use any calculators on the test?
You could use calculators, but as far as like the norm.sdist, you wanna do that for these kind of problems. But you can use the calculator, but you still have to show your work with the norm.sdist and the norm dist. Did that answer the question? Okay. Okay, any other questions on number 4? We're gonna have a mock test on Tuesday. We're having a mock test. Okay, percent of test takers below 70. Well, I want us to shade that area. What's the area below 70? Well, it's this area over here. We know there's 95% between 70 and 130. But what percent do we have below 70? So see if you can figure that out.
That is divided by 2 because it's both sides, so I said 2.5.
Oh, just fine.
Yeah.
Okay, so if we have 95% in the middle, that means we have 5% total on sides. But I just want one side, so this is one side, so that means I have to take my 5% divided by 2, which is 2.5%. What's another way to do this? In Excel, what do I want to enter in? How do we do this on Excel? Do you guys remember? Good. With Excel, you want to do the norm.s.dist. Do I want to put 70 in here though? No, I have to put the what inside? The z value. So I have to put -2 in for the norm.sdist. If you have Excel open, you can verify that when you put the -2 comma true in, it will in fact give you 0.025. So if you're using Excel, what do you have to do before you put the value into Excel? You have to find the z-values. You have to find the z-value first, and then you can do the norm.sdist of the z-value. Okay, questions on number 5. We're going to do another one. First, what is the name of the position where P% of the individuals scored at or below? A, B, C, or D? We're going to do a poll everywhere question. Okay, A, B, C, or D. What do we call that point in the value where P% falls below? So we're going to get poll. We have 6 responses. Okay, good. I hear some good answers. Our answer is good. C is the correct answer. We call that the percentile. So, percentile is the correct answer, C. So what's the percentile of the test taker who scored a 70? Quickly discuss with in your groups what you think the percentile of the test taker who scored a 70 is. Exactly, 70. We know that 2.5% of the test takers scored below a 70, so that will tell us something about the percentile. So let's write down what we believe the percentile to be. Okay, very good. So it looks like most of us are great on percentiles. There's 2.5% of the data below, so it's the 2.5th percentile. Okay, next we want to find the percent of test takers who scored below a 90. So we have to make sure we do something first, find the blank, and then enter something into Excel to find the percent of test takers that scored below a 90. So if you want to write your answer in norm.sdist, that's fine. So go ahead, form your groups of 2 and find what you need, and then write what you would enter into Excel.
Z value is negative 2/3, right? Yeah, so let's do.
It's just like this,
Okay, so then the position of data set where 50% scored below is called the percentile. So at 70, we got 2.5% scored below.
Yeah. Wait, hold on. Wait, do you put the standard deviation to find the 6? I know.
I don't think
Or do I put
you
0.90?
put the Z-score.
No, I have to find this too.
Yes, so the find the Z-score, you do 90 minus 100.
Oh, yeah, I don't need the norm. Sorry, okay.
Well, you do need the norm just.
But that's after.
Exactly.
Yeah, okay, thank you.
Good, you guys want to kill that?
Audrey, that's so funny that I literally was just talking. I actually just. Yeah, just talking about that.
Okay, let's go ahead and share. Okay, can I enter norm.s.dist of 90? No, what do I have to find first? Well, we call it the Z-score, which uses the standard deviation. Do we remember what the Z-score of 90 is? Good, well, we can do 90 minus 100 over 15, and that ends up being negative 2/3. And so then I'm going to do the Excel formula. Excel gives me what kind of areas, right or left? Left. So can I just do norm.sdist of negative 2/3 and get the answer? Yes. So norm, the answer is going to be norm.s.dist of negative 2/3, comma, true. So I'm going to go ahead and enter that into Excel. Now, some people like to do everything in one, and they like to do norm.s.dist of 90 minus 100 divided by 15, comma, true. That's another way to do it, but I just recommend doing it separately and then putting the negative 2/3 in. And we see that I get 0.25 as the answer. So the answer is 0.25 or 25%. Any questions on number 8? What if I wanted the percent of test takers above 90? What would I do? Good. If there's 25% that are below 90, that means there has to be 75% above 90. So anytime I ask for the area to the right, you have to do 1 minus, just like in the quiz today.
But that's only for symmetrical, right? Or is that?
That's always. Yes.
Yeah, are you going to test us on that?
That's not in for a while. We don't get to that until like a higher level test. So let's not worry about that until after this test, because it's not going to be on the test. So I don't want to have us worry about too much stuff. Okay, next we want the percent of test takers between 90 and 100. Let's see if we can form groups of 2 and find the percent of test takers between 90 and 100, and we may need to use Excel for this one. The percent of test takers between 90 and 100. Where we want to find words.
Wait, I don't, how do you find the z-square of this?
Oh,
We can
that's
either do
actually.
90 minus 100 over 15,
Wait,
or we can remember that
this
the
again?
z-square of
Wait,
15
what-
is 2/3, and then the z-square of 100.
What was
You add them
this?
together? Or,
So this is the one where we have the area in the middle, so we have to do.
no, I know how to like do the area in the middle and like this, but don't you need you just use the z-square of 90?
I was gonna say it's 50% minus.
We have to find the z-square of both of them, and then
Yeah.
put both of them into Excel and subtract.
Oh,
We're gonna
okay,
do
okay.
that, or, yeah. That was the way that you did it. Because I haven't checked to see if that's the way. I feel like that's more complicated than the. Yeah.
In my mind, it's still on.
Exactly. Good. And then you do it in Excel. Okay, good. Okay, let's do this in Excel. So I need to do the z values. What's the z value of 90? Z value of 90 is negative 2/3. And what's the z value of 100? 0. Why is the z value of 100 0? 100 minus 100 is 0. One way we can do this is we can use the z value formula, but the mean always has a z value of 0 because it's in the middle. And when you use the z value formula, I'm going to go ahead and just do it just to show that if you do the 100 minus 100 and then you do it over 15, you get 0. Okay, next we want to do these in Excel. If I do norm.sdist of 0, it's going to give me this green area over here. So the green area is norm.s.dist of 0. Is that the answer? No. I want the red area, which is the area in the middle. So how do I find the area in the middle? I have to do norm.sdist of this value over here. Let me put it in another color. Let's put it in purple, with this purple color. What's that purple color? How do we find that? It's norm.sdist of negative 2/3. So I want to do norm dot s dot dist of -2/3. And then what do I want to do with both of these things to be left with the area in the middle? Subtract. Good. So I'm going to subtract both of these things. And that's going to be my answer. So I'm going to do it in Excel. Equals norm dot s dist of 0, true minus norm dot s dot dist of -2/3, true. And I get 0.2475. Any questions on number 9? Last problem, we're going to go backwards. We just did z value to area. Now we're going to go back from area to z. So that's going to be our last bit of the lecture. So let's say we know that the z value is 2. How can we find the test score if we know that the z value is 2? Again, our mean is 100 and our standard deviation is 15. So if we have a z value of 2, what's that test score? So let's go ahead and write down the answer to number 10. It's 130, but good, I want us to use this formula here because it's going to get harder. So it's 130. Extra credit on the test?
Oh yeah, we should do that. Extra credit.
Not usually.
You should give an extra credit opportunity.
Yeah, they can all.
So let's go ahead and write down. Good, and that's correct, very good. 100 plus. Good, it's 100 plus 2 times 15. You guys are doing really, really good. You don't need to worry about extra credit. Okay, so z value of 2. Let's see the problem. Z value of 2 needs to add how many standard deviations? 2. Good. What am I adding the 2 standard deviations to? 100. So when I do that, I get 130. So the answer is 130. So what's our formula for the test score? Let's call the test score x. To do that, I'm taking x and then I'm doing 100, good, which is the mean, plus blank times blank. What's the second blank is 15. That's the standard deviation. What's the first blank? Z. So this is our formula to go the other way, to go from, we have the Z value. Exactly, it's the same formula, so we could just switch it around for whatever we need to do. Very good. Okay, determine the test score for the 97.5th percentile. So 97.5th percentile, that would mean that there's a certain percent to the left and a certain percent to the right. Let's do some shading. The 97.5th percentile is going to be somewhere around here. So what do we mean the 97.5th percentile? How much better did we do than everyone else? We did better than 97.5 and we did worse than. Okay, so that means
2.5.
good. So 2.5% to the right and 97.5% to the left. Let's do the shading and see if we can figure out what that test score is. We're shading the area, which is the 97.5%. So we're guessing it's probably 130, but we need to show some work on why it's 130.
Wait, but you didn't use some, 130 is
I don't think we did. No, we haven't done it yet. We did some similar problems, we didn't do one. It's kind of a hunch. Okay, so what's that area? 90?
Yeah, so it's 130.
Okay, yeah, we know that it's 130, but we need to show some reason on why it's 130. What percent is this? 97.5%. Good. Very, very good. Anytime we have the percentage and we want to find the z-value, norm inverse. So norm.s inverse. So type in norm.s inverse of 97.5%. What z-value do you think it's going to give you? Well, 130 is not the z-value, it's 2. Should that be a surprise that it's 2? No, because remember when we have the within 2 standard deviations is 95%, so we have the -2 and the +2, and then the 2.5% on the one side and the 2.5% on the other side. So let's go ahead and do norm.s.inv. So norm.s.inv of 0.975. So I'm going to do that. Equals norm.s.inv of 0.975. It's going to give me, okay, it doesn't quite give me 2. It gives me 1.96. But let's just round to 2 just to make things easier for today. It's approximately 2. So that means my z-value is 2. How do we know that the test score is 130? How do we find the test score? Let's use that formula at the top. Let's go ahead and use the x equals mean plus z times standard deviation to show that when you plug 2 into the equation, you get 130. So let's go ahead and do that. Oh wow, you did already. Very good. I want to see you guys plugging in. And we still have one more problem. For the last problem today, whoever gets it correctly will get extra credit on the quiz today, 1 additional point. So, but first let's do this problem. So, I just encourage you guys to stay for the last 3 minutes. So you're gonna plug it into this formula right. The x value is the 1/3. Because that's the value in the data set that we get. It's equal to 100 plus 15 times 2 because it's values. Exactly. Then you were able to.
I'm on it.
So why is it 130? Because it's 100 plus 2 times 15.
Yeah.
Okay, so we get the 2, so then how do we find that it's 130? Because it's 100, we'll use this one, 100 plus. Yes. That's on the right track. So we need to go over this one. Okay, let me go over this one and then we'll do the extra credit problem.
Can we all get extra credit?
If you get it right, you get extra credit. It's not just one person, whoever gets it. We have to do hold on. Before we do the extra credit problem, we have to do number 12 first. How do I get 130? Well, 130 should be equal to the mean. What's the mean? What's the mean? 100 plus, what was the z-value? 2. Multiplied by 15. What do you get? 130. Okay, for number 13, if there's 84% above, then then that means there's something below, and then you want to use a norm.s.blank to get the z value, and then use the formula to get the x value. So as long as you get the problem correct, you'll get an extra credit point on today's test.
Oh, I don't need
So
to.
that just gives you the z value, but then you still have to find the value on the data set. It gives you that gives you -1.
I'm gonna lose out on this extra credit point.
So that is, that's right. So you get extra credit, very good, Savannah.
I did not get extra credit.
I need to see one more step. So you do that, you get -1. Remember, that's what we have to do. I want to see it now. Just take a picture. I'll remember. Good. You did norm that as the IND?
Yeah, we did.
Okay, good. Good. You didn't just copy my killer, did you? Oh, I collected it. No, I'll remember. I'm just gonna count the number of people and Savannah, can I just get a picture of the problem?
Same problem. It's probably
Nicole, do you want extra credit? No. So when you do norm.s this, you get -1. And then you get that way, you get 2.115, you get about 85. Because that's pretty much -100 minus 15 is 81. That's okay, take your time.
I'm gonna look at what.
You got different answers? Yeah. You guys have the same answer. Did I photo yours again?
No, together. Or do you need mine?
I'll just take a picture of them. What value did you get?
85.
Okay, good. See, you guys are fine. Nothing to worry about.
Thank you.
You're welcome. Okay. Have a good weekend, guys. This is the new version of Microsoft Internet Explorer. It became Microsoft Edge
No, what this is? For your writing.
on Microsoft Edge.
Really?
It just came with my computer because it came with this
Because I have a
pen,
stylus.
and I just go like that,
I know.
and then like.
So this is Edge?
That's all I have to use, and then it comes with a built-in. I just double-click on the PDF. I save it as like a PDF. You can also do it in here, but I don't know. It never worked as well for me when I did it in the Word document.
Make your thing, you know. So that's just directly from Edge. Because I was like trying to see, what is that? That's different. It's very nice.
Oh,
I
thank
like
you.
it. Yeah. So in their exam on Thursday, am I proctoring still or?
Yes.
Okay.
The thing is though, my interview's from 12 to 1. Is it okay if I come a little late?
No, because I'm giving them a test.
Oh,
I'll just
okay.
take care of my class
Okay.
first. I mean, if you come in, it doesn't matter because I already am here.
You're ready.
So maybe next time. We'll
Okay.
get
I can do it
number
next time.
Yeah.
Yeah. Hopefully by then I'll be all done with the interviewing and
Yeah.
stuff
So
like that.
are they allowed to use their laptops during the test, or are they?
I'm gonna make them do it on those
Okay.
computers.
Okay.
What did you get for that one, Alina? Good, that's right. So you're good.
Well, see, the shirt. I think I